Hi all, welcome to my channel All About Jira. Today we are going to discuss about server and the database. So in this session we'll let you know what is a server, what is a database, how we use that. Let's quickly get into the session. So as we know, the architecture of web application is like this. First we have the client, and then we have the server, and then we have the database. So as we already discussed, client will send the request to server, and then server will send the request to database. After database has processed the query, it will send the information to server, and server will render the information and it will send the information to client. This is how our web application architecture works. So yesterday in our session we have completed the client. Today we are going to discuss about the server and database. Okay, so let me quickly clear this screen. So as the name suggests, so we are calling it as a server. As the name suggests, server is nothing but a computer where our application is hosted and exposed to internet or exposed to network. So server is nothing but a computer. So a computer means a powerful computer, not our normal laptops or PCs. It's a very big computer which consists of a huge RAM, storage, a very good processor, and which can handle the number of incoming and outgoing requests. Okay, so in these servers we have two types. We have on-premises, or we call it on-prem, and we have something called cloud. So we need to know the difference between on-premises and cloud. So what is an on-premises? On-premises is nothing but this server will be physically located at our place. At our place or our office or our place where all our servers are located, right? So if anybody asks you what is an on-premises, you can simply tell on-premises type of server means that physical server or that physical computer will be located at our place, and from here it will be exposed to internet. And here we need a separate server room, and then there we'll have to have the workers, air conditioning, network cables, network adapters, and all that. So next we are going to discuss about cloud. What is cloud? Sorry, wrong arrow. What is cloud? A cloud is nothing but here the server in cloud type of servers, the server will be located somewhere in the world. We don't know where it will be, but they are accessible and can be logged in remotely. So in cloud, servers are located somewhere in the world where the end users will put it or where the vendor put it, and we can access and log in into that server remotely. So that's why they are called virtual machines. They are not physical machines. You can log in and do all the work, but through virtually. There is no physical server here. It will be there, but It will be there, but it will be somewhere, we don't know. So that's why we call it as a virtual machines, or simply we can name it as VMs. People call it as VMs. So whether we need to select on-premises or cloud server for application, that depends on the business. If your company is having hundreds of applications, then on-premises is preferred. Why? We can have a server room, we can expose from to internet from there, we can have our maintenance, and the cost will be significantly reduced compared to cloud. Cloud is a bit costly because somebody will maintain their profits and all the softwares, we have to bear all the charges, so cloud is bit costly. But companies which are larger and they can have a team which can targetedly work on these on-premises servers, they can maintain this. Now, so cloud, who uses cloud? So the organizations which are pretty small and big, also big organizations also use them, so which are thinking to host their applications in cloud, so that they need not maintain anything because of the complexity of maintaining the on-prem servers, will go to cloud. So in cloud, as I discussed, there are different types of vendors who provides these VMs. So in the world, topmost is the Amazon Web Services. As you know, Amazon Web Service is the top vendor for this cloud hosted services. And then after Amazon Web Services, we have something called Microsoft Azure. So after Microsoft Azure, we have GCP. GCP means Google Cloud Platform. So after that, these three are the top, and we also have IBM Cloud, and there are some more other web services and cloud providers, but we need to know these four. These four are the very important in the market. The first three are the top. In those, other than this, everything is the web services is the top. So as you know, there is an interesting fact here. We have something called Amazon Retail. Amazon Retail means the app that we do for the shopping, and we have something called Amazon Prime, right? So Amazon Retail means Amazon Shopping, Amazon Prime, or any other Amazon products that we are directly using by the end consumers. They are always loss occurring to Amazon. So they run or loss. For example, we also have a e-commerce platform called Flipkart, right? So a product in Flipkart, if it has 100 rupees as listed price or the selling price, in Amazon there will be at least 90 to 92 rupees only will be there in Amazon. Why? Same product, same seller, but different platforms, different prices. Why? Amazon's prices are less compared to other platforms. Even if you have to compare Snapdeal, eBay, Amazon will be the very less price. So Amazon wantedly sell these items for loss, and they will gain something called brand value. So each and every person will get to know name of the Amazon, right? Not only the persons who are using in the IT industry in AWS, but also all the people will know Amazon. For brand value, they wantedly sell these products for lesser prices, and all the loss that incurred here will be recovered here. So this is a very less loss for Amazon, but the profit they gain from AWS is huge. So as you know, there are some jokes around Instagram and all. In an average project cost, 50% of the project cost goes to AWS services itself, and rest of the 50% goes to salaries, maintenance, and all of the office. Okay, so these are some important notes about the server. So we also have something called 7-layer architecture for a server, how web requests go, how web requests will enter and how it is exposed to internet through network host ports and all, but we need not concentrate them now. Just know up to now server is a computer where our application is hosted and it will be exposed to internet. That's it. Okay, this is about the server. Here also there is an important note that I forgot. 1 second. Yeah, so let's discuss about the database. Yeah, before going to database, I have to discuss one more note. So here in Amazon Web Service or Microsoft Azure, we have admins also for AWS and Microsoft. So they themselves can create VMs, and here we have some important term called auto scaling. Here we also have horizontal vertical scaling. So let's now remember as auto scaling. Auto scaling means if your VM is hosted somewhere, right? Let me clear this screen. If there is a storage here, this is in cloud, and my limit is 250 GB when I created the VM. So the users, all are users using this application at attaching the attachments and all, something is happening. So this limit reached to 250 GB. So after one user entered and attached a 1 GB attachment, for example. So immediately what auto scaling, Azure auto scaling or AWS auto scaling does is virtually increase this memory to 251 GB. So like this, depends on the resource allocation, we will be priced. So the advantages of cloud is you need not buy a physical server at once, but if you need 6 GB RAM, you can use 6 GB RAM. If you need 8 GB RAM, you can use 8 GB RAM. If you need 1 TB storage, you can use 1 TB. If you need 2 TB, you can use 2 TB. So after you started business, so that you will know only 2 TB of memory will used, but your limit crossed 2 TB. Automatically Azure auto scaling or AWS auto scaling, what it does, it will increase this memory virtually. So it will automatically increase after the 2 TB to 3 TB also, from 3 TB to 4 TB. That means here we have virtually infinite memory. We are having virtually infinite memory. We need not worry about the physical capabilities of this cloud, so they can go to anywhere theoretically. Physically also there is a limit, but theoretically it has infinite memory. So their data centers will share the load according to the requirement. But as long as this memory is being increased and the our server requirements is being increased, like RAM and all, processor and all, your pricing will also increase. We have to pay this amounts. So this is the one advantages of the cloud. So while creating the virtual machine only, we can select what type of operating system we need. We need Windows or we need Linux. In Linux also we have different types of operating system, like vendors, Red Hat, CentOS, like that. So we can select the particular OS version. Okay, now let's deep dive into the database. So what is meant by database? So database, so I am saying here a brief definition. Database is a software which stores the information of application, and it provides data as per the requirements and also updates the data as per the request. So simply we can say database is a software which stores the information of application and provides the data when we need as per our requirements, and it also updates the data as per the requests provided. Okay, so why we use the database? The first question. The answer is to store the data. That's it. Then what are all the types of databases that are present in the market? So there are two types of databases. One is the relational databases, and second one is the non-relational database. So what is meant by relational? What is meant by non-relational? A relational database is a database where our data is stored in tables. So this is the database that we use for Atlassian applications and our development as well, in the custom add-ons also. We need to concentrate more on the relational databases. What is a non-relational database? So where our data is stored in the form of folders and files, like our laptop, Windows OS. Here data is stored in form of folders and files. So what are the examples of relational database? What are all the examples of non-relational database? Let's discuss quickly. So here we have the most famous is the MySQL, and then we have MS SQL Server. So MS means Microsoft, and then we have PostgreSQL, and then we have Oracle. So these are the famous databases that are relational. In non-relational, we have many databases. So in that, one important one is the MongoDB, and we have HBase, Firebase as well. These are some of the examples of non-relational databases. Okay, so now quickly we'll discuss how relational database stores the information in the form of tables, how they are connected with each other. Just a brief, I will not tell much because we will discuss in the future all these requirements. Just I will explain the basics. So now I have a requirement. So we have an employee. So I will take a basic example of employee in an organization. What are all the factors when entered into the system when an employee joined, right? So employee will have his first one is the surname, next one is the full name, next one is the gender, next one is either married or not, that means marital status, and then we have address, and then we have surname, full name, gender, marital status, address, and we also have skill set that we are having. These are all the basic details that an employee is required to enter when he is joining the organization. Okay, so this is a basic example, right? When I am designing a database table for this employee, how I should design? There are some rules or standards. So this is the employee table. So database tables are like this. So as when I tell the term table, that means a table always has rows and columns. So what are the rows? These are the rows. These are the rows. In real time also we'll see this, but for example now I'm showing. So after our Jira is installed, I will show all the information, how it is storing the data in tables, how it is updating the data in tables and all. I will show you. Okay, these are the rows. Remember, these horizontal lines are called rows. These are called rows. And the vertical lines are called columns. If I draw a vertical line here somewhere in the center, these are called columns. This is a column, this is a column. So this is called column 1, and this is called column 2. So these are rows. This is row 1, this is row 2, this is row 3, row 4, row 5, row 6 and row 7. This is the column 1 and this is the column 2. Okay, so now I'm deleting this one. So for example, I'm only taking the let me delete this line. And insert the line again. Okay, so here let me take this table again. Show something. I have T. One second. Okay, let me build that table. Yeah, here I completed my columns and I am building the rows. So all our applications will store the data in form of this type of tables. We'll have number of tables connected with each other like this. Yeah. So here now we have different types of columns. In every table, the first column will be the ID. Remember, the first column will be the ID. This will be the primary key for this table. This will be the primary key. Sorry, this will not be the primary key. It depends. Okay, now we have surname. And then we have full name. And then we have the gender. We are only taking these three. We have ID, surname, full name, gender. So ID means the number of rows that the data is entered. So first will be the 1. The simplest applications will use the 1 as ID, but our Jira and all Atlassian applications will start storing the IDs from 10,000. Remember, all our Atlassian applications will store the ID starting from 10,000. So for instance, for simplicity now, I am selecting this as 1. So surname, I am selecting it as John, for example, and full name, I am selecting it as Smith. As we already know, there are 2 types of genders. How many types of genders? 2 types of genders. One is male, one is female. So there are only two types of genders. In all over the world, there is no change for this, right? So here, if I want to enter the information, either I have to enter the male or I have to enter the female, right? So these type of cases where the data is universal or it's fixed or it will won't change or it only changes based on special circumstances and it will be constant for most of the time, we have something called master tables. Let me remove this. We have something called master tables. So what is a master table? A master table is a table which has independent data in it. So what it has? Which has independent data and does not depend on other tables. Okay, so here what is the information that is independent? Gender, because it has only male and female. Okay, so now let's build another table called so this table, let's call it as employee table. This table let's call it as gender table. I'm only using small letters to define the table names, please remember. So this will be, as I said, all the database tables, the first column will be ID. This won't change. Here the second column will be name. What's the name? Gender, name. Here we have something called is active. In order to disable and enable, we will add an additional column called is active. In this is active, true or false will be there. That's fine. So ID, let me enter the rows. The first one is male and is active, we call it as true, because there are some instances that application, if this is removed from our organization, we have to set it as false. This for now you can ignore, but we will have a column called is active to filter. Now as a second option we have female. This is also for now is active is true. So while entering the gender, we will not write always male female male female male female, right? So we will just write 1. That means this Smith's gender is 1. 1 means male. So how we connect these tables? So these two tables will be interconnected with each other, with this column being primary key and this column being foreign key. So what is a primary key? What is a foreign key? Primary key is the primary column that we are using to refer the whole row, whereas foreign key is the key where a table is connected to the other table. So if you see here, this employee table is directly depending on the data on the gender table. Gender table data is independent, male, female, that's it. But if you enter second record, let's say here Mary and say here Gaur. So if her gender is female, we have to enter 2. 2 means female. That means employee table is depending on the options available on the gender table. But gender table is the independent table. So this is the dependent, this is the independent, or these types of tables we call the master tables. So these two will be connected with each other. These two columns will share the data. Yeah. So even our Jira has 369 tables in it. Wait, there are so many tables, right? So in this list, provide me a table. Let's consider these three as a table. So in these three, what is the independent table? What can be the independent table means marital status. So it only has married and non-married. That's it. So we can also build a table. We can add an additional column here, marital status, and build another table, link that column with that table primary key, make it a foreign key here, and 1212 we can write the IDs. So this is how database works. So the important information to note is how many database types are there, like how many types of the databases, relational, non-relational, how the relational databases works, examples of them will be enough for this session. So in the next session, I will explain what is a data center concept, and then we can start with our Jira introduction and we can move forward with the administration activities. If you like this video, please like, share, subscribe, and comment to my channel. And please share it with your friends who are interested to learn Jira admin course. This course may be little slow because I am giving all the in-depth information that is required for a person to completely learn and master these tools. Please watch it from starting to ending and you will gain the full skill that is required. Thank you once again. Take care. Thank you.